This is part 2 of section 8.1. So the last problem we solved by substitution. This problem we are going to solve by elimination. So in order to do that, we need to multiply either one or both equations by a non-zero number that causes one of the variables to be the additive inverse of itself in the other equation. So in this case, we have 2x plus 3y equals 1, and we have negative x plus y equals negative 3. So additive inverses are two numbers that add together to be 0. So 2 and negative 2. 4 and negative 4. So in this case, if we look at our two equations, we see that the x variable in the second equation is already negative. So if we multiply that whole second equation by a 2, and of course we have to do it on both sides, then we will have what we need. So we have 2x plus 3y equals 1, and when we multiply the second equation by 2, we have negative 2x plus 2y equals negative 6. So now we add those two equations together. The x's cancel, and it leaves us with 5y equals negative 5, or y equals negative 1. Now, once we have that result, which I guess we should have done in step C, but we did it all at once. Now we plug the y equals negative 1 back into our equations to determine what x is. So 2x plus 3 times a negative 1, I'm using the first equation here, equals 1. So 2x minus 3 equals 1. 2x equals 4, or x equals 2. Then of course we have to check. So if we plug into the second equation, we have negative x, so negative 2, plus y is a negative 1, which equals negative 3. Check. So our solution is 2, negative 1. Okay, I'm moving on to the next page. So on that example on the previous page, it was fairly simple. We only had to multiply one of the two equations. This one is a little more complicated. We're going to have to multiply both of them. But first, I want to get rid of this 2/3 fraction in the first equation. So I'm going to multiply both sides by 3, which gives us 6x plus 12y equals 2. Well, that looks a little better, because now 6 and 3, 6 is a multiple of 3. So if we multiply the second equation by a negative 2, I think we'll be good to go. So we have 6x plus 12y equals 2. And we're going to multiply the second equation by a negative 2, because remember we need negative of what we have in the first equation. And of course we can't forget to multiply the other side by negative 2. So if we do that, we have the first equation doesn't change. The second equation is now 6x plus 10y equals 20. So now when we add these two together, the x's cancel again, and we have 22y equals 22, so y equals 1. Now, we have to plug that back in to solve for x. So 3x minus 5 times 1 equals negative 10. So 3x minus 5 equals negative 10. 3x equals negative 5. So x equals negative 5/3. Now remember, we have to check. So 2 times negative 5/3 plus 4 times 1 does indeed equal 2/3. And I've been sloppy before. I've only been checking in one of the equations, but really we should be checking in both of them. So 3 times minus 5/3 minus 5 times 1 equals a negative 10, which is what it's supposed to. So both of them check out. So our answer is the point negative 5/3, comma 1. Okay, now we're going to talk about the past several examples have been where we had two separate lines that intersected at one point. Now we're going to talk about one of the other two cases. So now we're going to talk about where the two lines are parallel and how we can figure that out. Okay, so I want to eliminate the y's on this one, let's say. So the least common multiple of 4 and 6 is 12. So I need to multiply the top equation by a 3. So we have 3 times 6x minus 4y equals negative 4 times 3. And I'm going to multiply the bottom equation by a 2. And you notice the y's have opposite signs, so we're in good shape. Negative 9x plus 6y equals 18 times 2. Okay, so if we do the multiplication, we have 18x minus 12y equals negative 12. And we have negative 18x plus 12y equals 36. So now if we add these two equations together, well, the x's are gone and the y's are gone, so we're left with 0 on one side of the equation and 24 on the other. Well, now this statement makes no sense because 0 does not equal 24, right? So 0 does not equal 24. That means that this system is what we call inconsistent. And that means that there are no solutions, because these lines are in fact parallel. So if we find the slope and the y-intercept for each of those lines, let's see, 6x minus 4y equals negative 4. So in other words, transform these into slope-intercept form by solving for y. So negative 4y equals negative 6x minus 4. Then we divide by negative 4. So y equals negative 6x over negative 4 plus a negative 4 over negative 4. Or y equals 3/2 x plus 1. So continuing with the second equation, we have negative 9x plus 6y equals 18. So 6y equals 9x plus 18. Or y equals 3/2 x plus 3. So these lines are parallel. How do we know they're parallel? They have the same slope, but different y-intercepts, which, since they're parallel, the system has no solutions. And again, that's what we call inconsistent.